Welcome to the YouTube channel PCMB Tutorials. I hope you all are fine. Today we are going to learn class 9th heat part 2. So in this part we are going to start with kinetic theory of matter. Kinetic theory of matter postulates according to the kinetic theory of matter, matter is made up of molecules. Molecules which constitute the matter have three kinds of motions: vibratory, rotatory, and translatory. The vibratic kinetic energy of solid is maximum, liquid is moderate, gas is minimum. The rotatory kinetic energy of solid is minimum or negligible, liquid is moderate, gas is moderate. Translatory kinetic energy of solid is minimum or negligible, liquid is minimum, and gas is maximum. Let us see what happens when heat is transferred to a substance, say a gas where molecular force of attraction is practically negligible. When extra heat is transferred, the things happen are molecules or atoms vibrate more vigorously, that is, increase in vibrational kinetic energy. Molecules or atoms rotate much faster, that is, increase in rotational kinetic energy. Molecules or atoms move more rapidly from one point to another, that is, an increase in translational kinetic energy. The heat is transferred to a gas in the form of kinetic energy of the particles of a gas. The excess heat energy to the gas is distributed as three types of kinetic energy. Now let us study the effect of heat on solids and liquids which have intermolecular force of attraction. We are aware that when heat is transferred to solids and liquids, they tend to expand. The expansion is due to loosening of molecules. This loosening occurs only when the intermolecular force of attraction is overcome. To overcome the intermolecular force of attraction, the part of heat is transferred is taken to consideration. But according to the law of conservation of energy, the energy cannot be destroyed. So the energy that is taken to loosen up the molecules remains in matter as stored energy. The stored energy is potential energy. The remaining heat is changed into kinetic energy. We can now conclude that in solids and liquids, heat exists in the form of kinetic energy and potential energy. The sum of potential and kinetic energy of particles of a substance is known as internal energy. Of the substance. Hence, heat can also be defined as the measure of internal energy of a substance. Now, we are going to learn heat as waves. We know that heat can exist in the matter in the form of kinetic energy as well as potential energy. Interestingly, heat is also associated with waves. The heat waves are electromagnetic in nature and are known as infrared waves. The heat transferred from sun to the earth in the form of infrared rays. The existence of heat in the form of electromagnetic radiation gives heat a unique advantage. It can move rapidly at the speed of light in air, vacuum, or space. Infrared waves have a wavelength of 7,000 angstrom to 40,000 angstrom. 1 angstrom is equal to 10 raised to minus 8 centimeter. Now, measurement of heat. Measurement of heat. The branch of science that deals with the measurement of heat is known as calorimetry. Calorimeter. The vessel which is used for the measurement of heat is called a calorimeter. It it is usually a cylindrical vessel made up of copper with a strier. It's used as it is a good conductor of heat. The units of heat are first and oldest, practical. Calorie, it is CGS unit of heat. CGS unit of heat is calorie. It is defined as the heat required to raise the temperature of 1 gram of water through 1 degree Celsius, strictly from 14.5 degrees Celsius to 15.5 degrees Celsius. CGS unit is energy, unit of energy, ERG. SI unit is joule. Bigger unit is 1 kilocalorie, that is 1000 calories. Relation between joule and calorie is that 1 calorie is equal to 4.18 joule. 1 kilocalorie 1 kilocalorie is known as 14.18 into 10 raised to 3 joules or 4180 joules. There are some factors affecting the amount of heat energy transferred. Factors affecting amount of heat energy transferred. For that, we'll see two activities. Activity 1. Take two identical beakers A and B. Pour 100 gram of water in the beaker A and 200 gram of water in the beaker B. Now heat them through 20 degrees Celsius rise in the temperature. Which one will absorb more heat to the raise their temperature through to rise their temperature through 20 degrees Celsius? Beaker A or beaker B? We observe that water in beaker B takes more time to raise its temperature through 20 degrees Celsius. That is the amount of heat absorbed by water in beaker B is more than that of water absorbed in beaker A. The quantity of heat absorbed by water depends upon its mass for a given rise of temperature. The greater the mass, the more is the heat required to raise the temperature. That is, Q is directly proportional to N. Activity 2. Take 100 gram of water in two identical beakers A and B. Heat the beaker A through 20 degrees Celsius, rise in temperature, and beaker B through 40 degrees Celsius, rise in temperature. Which one will absorb more heat, beaker A or beaker B? We observe that water in beaker B takes more time to raise its temperature through 40 degrees Celsius. That is, water in amount of heat absorbed is more for the water in beaker B to rise its temperature than the water in beaker A. In conclusion, the quantity of heat absorbed by water depends on the change of temperature for given mass. The greater the change in temperature, the more the heat is absorbed. That says that energy, heat Q is directly proportional to change in temperature, delta T. From this all activity, it is clear that the amount of heat absorbed or given out by a body depends on the mass of substance, the change in its temperature. So combining these both equations, we get Q is equal to Ms delta T, change in temperature, where Q is the amount of heat transferred, M is the mass, change in temperature, delta T, S is the proportionality constant called specific heat. Thus, the quantity of heat required to heat a substance depends on mass of the substance, specific heat of the substance, rise in temperature. Note that the value of specific heat is a constant for a given substance and depends on the material of the substance. Our next topics are specific heat, significance of specific heat, liquids having lowest and highest specific heat, and we'll solve some problems based on this whole theory. But in part 3, I hope you've understood this part 2. Like, this is the foundation of class 9. We have covered the foundation of class 8th and 7th too. The links are given in the description. Please go and check through it. I hope you have understood. Thank you for watching. Let us meet in part 3.